Welcome to your first video for conceptual physics. This is Mrs. Reiki,
And this is Mrs. Kane.
and we're going to be covering sections 1.0, which is the introduction, through 1.2. So this is chapter 1, the first couple of sections.
And as we're going through these sections, you're going to need to have your notes out in front of you, and you'll be filling in the blanks from what you see in the PowerPoint to what's in your notes.
And also, if you have questions or have things that you care about, make sure that you note those also. So chapter 1 is about science, and for each chapter you're going to see something called the big idea. And in your notes, this is the first thing that you're going to fill in on that line right there at the top of the page. Science is the study of nature's rules. And if you need more time to write, hit the pause button.
And we'll just keep going. So for our intro, we just said that science is about rules and following those rules. And we are enriching our lives to understand the connections between things. It adds richness to the way that we see our world, just like how practicing a sport or studying a sport a little bit more helps us to appreciate that sport. The same thing happens with science, and that the more we study our natural world, the more we appreciate it.
So even if you're not going to be a physicist, it hopefully will help you, studying physics a little bit will help you appreciate and see some of the beauty that's in the world around us a little bit more fully. Science really began before people began writing things down, before recorded history. Early cavemen watched the stars, the weather. And why was that important? Because they looked for patterns. And when they saw patterns, they could make predictions. When should we plant our crops? When does the dry season come? When will the rainy season come? So that really is what a lot of science is about, is looking for patterns so that we can make predictions.
And then there's a blank in your notes that asks the question, what is science? And you guys are going to take a second to write down what you think science is. And then in a moment, we'll give you what we think the real definition of it is.
I don't know, it's the real definition. It's the book definition.
Right, that's true. That's true.
So
right, yours doesn't mean that yours is wrong.
So we're defining science as the facts, the body of knowledge about the workings of nature, but also just as important and maybe more important, it's the methods used to find out and discover those facts and patterns. So science is not just a bunch of facts in a book, but science is ongoing all the time around the world, and that's how science is done is a big part of what it is. So we say that science is a way of thinking and the body of knowledge that is attained from the processes of science.
In other words, it's organized curiosity, and curiosity is a wonderful thing. Most scientists just ask themselves how something happens, why it's happening, what is making it happening, and their curiosity is fueling them to answer these questions. Okay, the next section, section 1, the basic science, is physics.
Natural philosophy, which was philosophy has been around since the ancient Greeks. Philosophy, you can still take it in college, and it's a course of study that asks questions and then answers them. And natural philosophy is asking questions about nature. Why do things, what makes things go up and down? What is all matter made of? And the earliest people began to ask those questions, and the Greek philosophers answered a lot of those using logic and reasoning. The current, what we call science now, made a fork in the road, kind of, and moved away from philosophy because scientists began performing experiments. And that's what makes philosophy and science different. Philosophy and religion really ask questions and answer them, but science goes a step farther and uses experimentation to see if those answers really are correct.
And oftentimes philosophy, science, and religion all go hand in hand.
Right. I'll try ways of trying to understand our world.
Okay, there are two main groups of science. The first is life science, and basically it's the science of life or the study of living things. So some examples of life sciences are biology, anatomy, zoology, and botany. And you may not know what some of those are, but if you look at the word, you can kind of break it down, and there are usually clues in there. So take zoology, that word zoo in there, you know, we see whenever we go to the St. Louis Zoo and see all the animals. So zoo is a Greek prefix for animal, and so it's the study of animals. Botany is the study of plants, and you can think of, you had the example of the Missouri Botanical Gardens.
One of the most famous gardens in the United States.
Right here in St. Louis, and so the study of plants. Anatomy is the study of the human body or just animal bodies, and biology is the general study of life.
Physical sciences then study all non-living things. So how is matter put together? What about the stars and the planets and comets and meteors? And what about just forces and energy? And what about the earth and earthquakes and volcanoes? Those are all study of non-living things, and those are the sciences of physics, chemistry, geology, and astronomy. So why is physics the basic science?
Whoa, do you notice that, Mrs. Ricky? Do you think that that's yellow?
I tried to make them very aware, excuse me, that this is an important idea for this section. In your notes, the important ideas, kind of the checkpoints for each section, are in italics and bold. So this is the main idea of section 1. Physics is about the nature of basic things. Motion, all things move. The earth moves, the stars move, the planets move, people move, everything moves. So studying what causes motion is basic to all the other sciences.
And what are the forces that act on motion? What kind of energy does that require? You know, it's all connected.
So all of these topics that we're going to be studying in physics, really, if you understand these general ideas, then they're applied more specifically to other things like humans or animals or plants or planets or stars. But they all share these basic things in common that we study in physics. So that's why we do this physics first program.
Remember how we talked about how science is all about making connections? Well, here's a good example of that. You guys haven't taken chemistry yet, or maybe you did a little bit in middle school where you took some, and we're going to take a little bit this year too. But chemistry studies how matter is put together and how it combines. Well, you might not think that that really applies to you, and that biology might apply more because biology is the study of living things.
All cells are made of matter. All living things are made of matter. And so physics is what ties all of these subjects together. These ideas that we study this year in physics, we apply later in the other sciences.
The ideas of physics are fundamental to the others. Help us to understand.
Your favorite subject next to science, I'm sure, is math, and mathematics and science do go hand in hand. This is conceptual physics, so it is not as much of the math. When you take senior physics, you study more of the mathematical relationships between things than we do at this point. But math, we do use math because math helps make things more concrete. In the 17th century, it was discovered that nature could be analyzed and described mathematically. People began to measure quantities. And it makes things, our observations, much less ambiguous. That's a nice word, isn't it? We have a good example. You've seen both of us standing in the classroom.
Yes.
Well, I have a grandson who's 5 years old, and he's about 3 foot tall. So he says, "Gosh, Nana, you're so tall. I can't wait till I can be as tall as you are." But you've also seen me standing next to Mrs. Kane, and you say, "Gosh, she's really short. Mrs. Reiki is really short compared to Mrs. Kane."
And then someday you'll probably see me standing next to my husband, and you'll say, "Wow, Miss Gisselle's really short," or "Mrs. Kane's really short." So that word tall isn't something that's the same for everybody.
And that's what the word ambiguous means. It means unclear. It's not a very good descriptor. So how could we describe my height much more accurately so that other people have a better idea of how tall I am? We could measure it, and we could use numbers and say, well, Mrs. Reiki is 5 foot 4 inches. That's the benefit of using numbers and measurements and math.
When scientific findings in nature are expressed mathematically, using numbers, using equations and calculations, they're easier to verify or disprove by experiment. So it's easier to say, well, what is tall and what is short, compare when you have numbers involved and when you're using measurements in math.
And we're going to talk about experiments a little bit later on. But experiment is key to science, and scientists have to share their work and have other people repeat it. And how can you know that you've set things up the same way or you're getting the same results unless you make your observations very unambiguous, very clear as we want them to be? So we use math. And you'll notice again that this is a main idea. It's a checkpoint.
Yellow.
It's in yellow for us, and it's in bold and italics in your notes.
Okay, last point here. Equations are used to express relationships between concepts.
And we do use, some equations already. Area equals length times width. That speed is distance divided by time.
Miles per hour, right?
Is how we measure speed. So equations do help us define relationships. And so we do have some equations. You don't have to memorize them in this class. We always give you an equation bank, so don't let that scare you. You might have to learn a lot of equations. You just have to be able to use them. So we're finished with this section, but Ms. Kane, what would be a good question for the students to fill in on their form that they're going to fill out for us?
Well, you guys are starting off with just the basics of science, so how about in that form you answer and give an example of one life science and one physical science. Think that's okay?
Sounds good. So you fill in that form, and that's our way of knowing that you watched the video. We also will be checking your notes to make sure that they're filled in.
All right. You guys in class.